In this video, I'll show you how to make an iPad controlled SeaPerch. Here's a parts list as well as potential sources for these parts. But don't feel bound by this, as there are many places where you can find these things. These are the tools that you'll need in order to build this SeaPerch. This is the schematic for the SeaPerch. It contains a wiring diagram as well as where all the connectors go. You will need to refer back to this later as we talk about assembly. The first thing we want to do is modify our electronic speed controls. Electronic speed controls, or ESCs, take the voltage output from the battery and control what goes to the motor. The user tells the ESC how fast they want the motor to go, and the ESC outputs the correct voltage to the motor to make it go as fast as the user wants. These speed controls came with Tamiya connectors stock, which are too big for what we need them to do. So we need to get rid of them. So take your wire cutters, cut the wires as close as you can to the connector, and throw it away. We don't need it anymore. Take one of your Dean's connectors, and after stripping away a little bit of wire casing from each of these two wires, slide some heat shrink tubing down all the way to the base. Then solder the black connector to the negative side of the Dean's terminal, or the Dean's connector, and the red wire to the positive terminal on the Dean's connector. After you've done both solders, slide the heat shrink tubings back up and heat them to protect the connection. We need to do this on all three of our ESCs. On two of the ESCs, we need to modify the receiver plug. The red is the positive power, the black is the negative power, and the signal is the white wire. We don't want all three electronic speed controls to bring power into the WIRC, so we need to pull out the red connector on two of the electronic speed controls. So to do that, you can just push in on that gold with a little pen or with an X-Acto knife and pull out. I've already pushed down and got it out of the way so I could just pull it out with ease. And then you want to tape it back, something like that. This battery also came with a Tamiya connector, and it takes up too much space, so we need to remove that as well. So we follow the same process. You just clip the Tamiya connector as close as you can and replace it with the Dean's connector by stripping the wires, sliding some heat shrink tubing down, and soldering to the appropriate terminal. Now when you're using the battery, or when you're modifying the battery, you need to be very careful, because if you touch a metal part or a metal tool across these two contacts while they're open, it's going to cause a spark and you could burn yourself or shock yourself or burn the battery. So you don't want to do that. So you cut one at a time, be careful not to cut both, and you tape one to the battery like that. So you'll have just one free and you'll work on one at a time. The WIRC comes with a sort of wiring harness, but we need to modify it to fit our needs a little bit better. So again, this will come with the Tamiya connector. There'll be a Tamiya connector here, which we will have to remove. So using the same methods we used on the ESC, replace this Tamiya connector with the Dean's connector. We won't need to modify this at all. This plugs into the WIRC and provides power. The WIRC takes a little more power to work than most RC receivers, so that's why Densian sends this with each one of their WIRCs. We'll also have to modify it to fit 3 ESCs. Now the way we're going to do this is to make 3 parallel branches. We want 3 parallel branches because in parallel branches the voltage is the same, and we want each ESC to get the same voltage, because that means the same voltage will go to each motor, so they'll act the same and they'll have the same power output. If we didn't wire them in parallel, then the motors would behave differently and it would be a lot more difficult to control the SeaPerch. So in order to make this wiring harness, we need to cut 3 positive wires and 3 negative wires from the stock wire that you have. And once you cut them, you splice them together, you just twist them together as in this picture. And you solder them to the positive connector from here that goes to the battery. And you'll do the same thing with the negative. You take your 3 wires that you just cut, twist them together, and solder them to the negative wire here. Once you've done that, you'll need to take one positive and one negative and put it into a Dean's connector, another positive and another negative, put it into another Dean's connector, and the third positive and negative into a Dean's connector. Make sure each Dean's connector has one positive and one negative, or otherwise the electronic speed controls won't work and your SeaPerch won't work. Now we'll work on assembly. We're going to use our battery as the main frame for our SeaPerch and attach all the components to it using the Velcro strips. But before we start assembling, we need to attach two ESCs together. Make sure the receiver connector wires are all facing the same way and attach them heat sink face to heat sink face, just like that, and attach it with tape. Now assemble everything as shown in this picture. After experimenting with different setups, I found this way to be the best as it easily slides in and out of the mouth of the mason jar. Using Velcro strips, attach the components to the battery. Use as many or as few as you wish, but make sure that the whole assembly is able to fit through the mouth of your mason jar. Now we'll work on our housing. Take your mason jar lid and machine using a lathe or drill a hole large enough to fit your PVC reducer bushing through. Seal both sides with plumber's goop and let cure. After curing, seal it further with liquid tape. Take your other PVC reducer bushing and ensuring that the flange is on the opposite side of the connectors, pass your wires through and seal with epoxy and let cure. Then seal further with butyl tape. After completing the assembly of the SeaPerch and making the connections as shown in the schematic, connect the ESC output wires to the motor wires using the bullet connectors here. Also connect the Wi-Fi dongle USB cable. To provide a waterproof seal, the rubber hose should be fastened tightly to both ends of the bushings. To test that the SeaPerch has been assembled properly, switch on each ESC switch and listen for a sound from the motor. Also, look for the LED on the WIRC. It should light up and it will flash quickly when the Wi-Fi network has been created. If everything's been built correctly, you'll be able to connect your iPad to the Wi-Fi network and be able to connect to the SeaPerch in the WIRC app. Once you've done that, you'll get a video feed from the SeaPerch, which is a live feed, and you'll be able to control the motors using these on-screen joysticks, as you can see. You can now use your iPad to control the SeaPerch underwater, as well as view and record live video from the onboard camera. Feel free to explore the features of the app, as there are a lot of options that you can change to suit your personal preference. But remember, when using your SeaPerch, do not get the Wi-Fi dongle wet, as you will disrupt the connection and be unable to control it. Here we can see it in action. We can see how the webcam works and the quality of video that it returns. If you have problems with your SeaPerch, first check to make sure that your setup matches the wiring diagram as shown previously and that each motor is connected to only one ESC. If you still have problems, feel free to contact me at the email in the description.